Today we are discussing about MAKAUT's previous year soil mechanics question. First, Group A, short answer type question. Here, question number 1 is the apparatus that is suitable for conducting drained, undrained and consolidated drained shear test is. Answer will be triaxial test system. Next question is the maximum size of grain of clay is about, it will be less than 2 micron, that means less than 0.002 mm. Next question is water present in the voids of soil mass is called soil mass water or soil water. Next question is the coefficient of permeability of clay is not more than 1 into 10 to the power minus 6 centimeter per second. Here centimeter per second will be the unit of permeability. Next question is seepage force is the energy transfer between soil and water. Next, stresses due to self-weight of soil is known as geostatic stress. Geostatic stress. Next, the maximum water content of a saturated soil at which a reduction in moisture does not cause a decrease in volume of soil is called shrinkage limit. We know three types of Atterberg limit: liquid limit, plastic limit, and this one the shrinkage limit. The critical height hydraulic gradient observed for sand boiling condition is given by IC equals to G minus 1 by 1 plus E, but G is the specific gravity of the soil and E is the void ratio present in the soil mass. The average velocity of flow that will take place through the total cross-sectional area of soil under hydraulic gradient is known as coefficient of permeability. Next question, the relationship between seepage pressure, which is denoted by PS, and hydraulic head, which is denoted by H, is given by PS equals to gamma W into I into Z. Z is the depth of the soil and I will be H by Z. H is hydraulic gradient. A soil is said to be well graded if coefficient of curvature lies between 1 and 3. The surface tension of water in dyne per centimeter unit is 72 dyne per centimeter. These are the short answer type questions. Now coming to the group B. First question is a soil sample of coarse sand 15 cm high and 5.5 cm diameter was tested in a constant head permeameter. So first we consider that here it is given constant head permeameter. So the test will be constant head permeability test. For this test, taken sample height is 15 cm, which is denoted by capital L, and diameter of that sample will be 5.5 cm. Next, water permeated through the soil under a hydrostatic head of 50 cm for 5 seconds. So the hydrostatic head 50 cm, which is denoted by small h, and time t is 5 seconds. Now the question is, water was collected and was found to weigh 500 gram. Find the permeability of soil in centimeter per second. We have to find the permeability of soil in the unit centimeter per second. So the collected water weighs 500 gram, which is equals to 500 ml. It is denoted by capital Q. For constant head permeability test, formula is K equals to Q by T into L by H into 1 by H. From the diameter, we have to calculate A will be pi by 4 into d square. By using this formula, we get area is 23.758 centimeter square. Putting the value of Q, T, L, H and A, we get the coefficient of permeability equals to 1.263 centimeter per second. Now question number 4. Calculate the stress in a soil mass 6 meters below the center of uniformly loaded circular area of radius 1.5 meter with a pressure of 60 kilonewton per meter square. Here, depth of the sample is 6 meter, radius will be 1.5 meter and applied load is or applied pressure is 60 kilonewton per meter square. For uniformly distributed loaded area, the formula of stress will be sigma z equals to P by pi into Z by R square plus Z square whole to the power 3 by 2. Putting the value of P equals to 60, Z equals to 6, R equals to 1.5 and again Z equals to 6, we get the stresses in soil mass for uniformly distributed loaded will be 14.22 kilonewton per meter square. The next part of the question is thus obtain the exact depth at which stresses reduced to 50% of the applied load. Here stress reduced to 50% of the applied load, so the sigma j will be 60 into 50% equals to 9 kilonewton per meter square. Again applying the same formula, we are putting Qz equals to 9, P equals to 60, R equals to 1.5. We have to calculate Z. Z will be 2.23 meter. Next question is a cohesive soil has an angle of shearing resistance of 15 degree and cohesion of 35 kilonewton per square meter. If specimen of the soil is subjected to a triaxial compression test, then find lateral pressure in the cell for failure to occur at total axial stress of 300 kilonewton per square meter. So here the soil, given soil sample is cohesive soil, angle of shearing resistance phi is 15 degree, cohesion will be C equals to 35 kilonewton per meter square, total axial strain which is given in the question is 300 kilonewton per meter square. We have to calculate the lateral pressure. Formula will be sigma 1 equals to sigma 3 into n phi plus 2 into C into root over of n phi, but sigma 1 equals to total axial stress and sigma 3 equals to lateral pressure. First, we have to calculate the value of n phi, where n phi equals to tan square 45 plus phi by 2. Putting the value of phi equals to 15, we get the value of n phi, which is equals to 1.698. So, from this formula, we get sigma, putting the value of sigma 1 equals to 300, n phi equals to 1.698, C equals to 35, and again n phi equals to 1.698, we get sigma 3 equals to 122.96 kilonewton per meter square, which is the answer of this question. Now question number 6 is to find the coefficient of permeability of clay. The permeability test was carried out in a variable rate permeameter having diameter of the sample container to be 10 cm. Initial head of water in the standpipe was 45 cm. Observed to a drop of 30 cm in 3.25 minutes. If the sample is 15 cm high, the diameter of the standpipe is 1 cm. Then find the coefficient of permeability of clay in meter per day. First, we know that the permeameter will be variable rate, so the test will be variable rate permeability test. diameter is 10 centimeter, initial head is 45 centimeter, final head is 30 centimeter. So H1 will be 45 centimeter, H2 will be 30 centimeter. Time T is 3.25 minutes. Sample height is 15 centimeter and standby diameter is 1.9 centimeter. From diameter of the soil and diameter of the standby, we have to calculate the diameter, area of soil and area of standby. Area of soil is 78.54 centimeter and area of standby is 2.835 centimeter. Now the formula is K equals to 2.3 into A by L, A into L divided by A into T into log 10 H1 by H2. Putting the value of this, we get permittivity K equals to 0.0674 centimeter per minute. But we have to calculate this in meter per day. So first divide this answer by 100 and again multiply this answer by 60 and 24. So we get the unit is meter per day and the answer will be 0.971 meter per day. So this is the elaboration of the question of group A and group B, and group C question will be elaborated in the next video. Thank you.